Welcome back everyone, Patrick here, moving on to the next video, more factoring questions with decomposition. We have to factor each of these over here. So notice that these particular quadratics compared to the previous ones, notice here that the C value is going to be negative. It's actually positive here, but because there's a negative 2 as a leading coefficient, we're actually going to factor out a negative, and that's going to turn that C value to a negative. But all of these C values are negative, and then notice the B values, they're a combination of positives and negatives. So same exact process is going to apply. It's just I want you to keep track of all these different scenarios that we're working with. So initially we start off with positive B values, positive C values. Then we went to negative B values and then positive C values. And now we have negative C values and a combination of positive and negative B values. Right, so let's start off with the first one. We got x squared minus 2x minus 8. So as usual, first thing we look for, can we factor anything out? And notice in this case, we can't factor out any numbers, can't factor out any variables. So let's go into the decomposition steps. So first thing we do, a is equal to 1, b is equal to negative 2, c is equal to negative 8. We write out the a, b, and c values. Then what we do is we multiply the AC values. So 1 times negative 8 is negative 8. And then what we do is we find out two numbers that multiply to that AC value of negative 8 and add up to that B value of negative 2. And here is usually where there's going to be a combination. Whenever the C value is negative, it's going to be a combination of positive and negative values, right? Because you can't have two positive values because that would give you a positive number. You can't have two negative values because that would also give you a positive number when you multiply them. So whenever the C value is negative and you're doing decomposition, these two numbers you get, it's always going to be a combination of positives and negatives. So that's what's a little bit different than the previous videos that we did. So if we got negative 8, two numbers that multiply to negative 8 and add up to negative 2, well, that would be negative 4 and positive 2. Right? Negative 4 times 2 gives us negative 8, and the negative 4 plus 2 would give us negative 2. So what we do is we then decompose that middle value into these two values. So it'd be minus 4x plus 2x minus 8. Like that. Now, as I'd mentioned before in the previous videos, because this A value is 1, then once you get these two numbers, you actually know that the factors are going to be x minus 4, x plus 2 is just going to be those two numbers that you found over here. So that's eventually what we're going to get, but as I mentioned before, I'm going to go through this whole process of factoring by grouping because not all quadratics you're going to get are going to have an A value of 1, right? This only works, this shortcut to the answer only works whenever the A value is 1. But when it's not 1, you're going to have to go through this process. So I'm always going to be going through the same process, the full process, in order for you to get comfortable once we run into those quadratics where that A value is not 1. All right, so from here, let's factor this by grouping. So from these two, notice we could take out an x, so we'd be left with x minus 4. From these two, we could take out a positive 2, which would leave us with x minus 4. And as usual, we should be left with the same bracket, so we can take out that binomial common factor, and then we'd be left with x plus 2, like that. All right, and notice that's the exact same answer that we were aiming to get. All right, so this here factors into x minus 4. X plus 2, like that. Okay, moving on to the next one, part B. So we got x squared plus 6x minus 27. As usual, first thing you look for, can you take out a greatest common factor? And you can't in terms of the numbers, and in terms of the variables, you can't take anything out. So let's go into decomposition. Let's write out the A, B, and then C. And then what we do is we multiply the A and the C. 1 times negative 27 is negative 27. Let's find two numbers that multiply to negative 27 and then add up to that B value of positive 6. When you try out a few different combinations, you would end up with 9 and -3. Right? Notice that 9 times -3 would give you -27, and then 9 plus -3 is like 9 minus 3, which would give you +6. You got to be careful and not put -9 and 3, right? Even though -9 times 3 does give us -27, notice -9 plus 3 gives us -6. And that's not the b value we're working with. We're working with +6, so it's got to be +9 and -3. Okay, because the a value is 1, we know as a shortcut that that's going to end up being our final answer. Those two numbers we could just put here, but let's go through the whole process of breaking down, decomposing. That's where the name comes from. Factoring by decomposition is because we're breaking down or decomposing that b value to these two values that we found, like that, and then we factor by grouping from here. So from these two, we could take out an x, and then we got -3x minus 27. Whenever there's a negative here, you always take out a negative number, and we could take out a -3. So we'd be left with x. -27 divided by -3 gives us +9. And as expected, that bracket should always be the same. So we could take out that bracket, factor out that bracket from both of these terms, and we'd be left with an x minus 3, which is what we were aiming for. So this over here would end up being x plus 9, x minus 3, like that. Let's move on to part C. So we got x squared minus 9x minus 10. First thing we look for, greatest common factor. We can't factor out a greatest common factor, so let's go into decomposition. The a value is 1, the b value is -9, the c value is -10. What's the ac value? -10 times 1 gives us -10. So we've got to find two numbers that multiply to that AC value of -10, add up to that B value of -9. And here, what would work? -10 and +1, right? -10 times +1 would give us -10. -10 plus 1 would give us -9. Right, so those are the two values. So we know because the a value is 1, we could do a shortcut here. We know our final answer is going to be x minus 10, x plus 1. But let's go through the whole process of decomposition. Right, we took it, and then we took that -9x, decomposed it to -10x plus 1x, and then we factor by grouping here. From here, we could take out an x. So we'd be left with x minus 10 with these two. And then from here, we got 1x minus 10. Can't take out any numbers here. So whenever you have something like this, you just take out that +1 that's in front. Right? If it was a -1, then you would take out a -1. Because it's a +1, we're just taking out a +1, and you're just left with that same thing. And the reason why you want to do that is so we have that same bracket that we could factor out, and we'd be left with x plus 1, like that, right? So we end up with what we were aiming for. So part C over here, it factors into x minus 10 times x plus 1. Now moving on to part D, it's actually kind of similar. We got x squared minus 10x minus 9. Right, so it's just basically from here, the b and c value have been switched around. So let's see what we could do here. First thing we check, greatest common factor, can't take out any numbers, can't take out any variables, so we can't factor anything out initially. So let's go into decomposition. So we got an a value of 1, we got a b value of -10, we got a c value of -9. Then we multiply the a and the c value, which would give us -9. So then we find two numbers and multiply to -9, then add up to -10, like that. So from here, notice that there is actually no combination here that's going to work out. Because even if we do like -9 and +1, well, -9 plus 1 would give us -8. It's not going to give us -10. What if we do 9 and -1? Right, it would work over here, but over here 9 plus -1 is like 9 minus 1, which would give us +8. So that wouldn't work either. Now, this would have worked, I want to mention, if this was a +10. If this was a +10, no, sorry, not if it was a +10. Let me think here. If this was a +9, right? If this was a +9, see, that's why you got to be careful with these signs and stuff. It could get tricky because sometimes, depending on the combination, it sometimes works, but then if you switch them around a bit, sometimes it doesn't. If we had this over here, then -9, -1 would work, right? Because -9 times -1 gives us +9, then -9 plus -1 is like -9 minus 1, which would give us -10. Right? So if it was like this, then it would work out. But because this here was a negative, there's no combination that that's going to work out, right? Even 3 and -3, that would just net out to 0 when you add them. That's not going to give us -10. Okay, so there's no integers that satisfy this over here. So part D, this is actually not possible. Right, so I just wanted to throw in an example like that where it's very close, right? We just switch the B and the C value, but even with a small change like that, it goes from a quadratic that can factor to a quadratic that can't factor. All right, so part D is impossible. Now, what about part E? We got x squared plus x minus 6, like that. First thing we check, greatest common factor, can't take anything out at this point, so let's go into decomposition. The A value is 1, the B value is also 1, and then the C value is -6. The AC would be -6, find two values that multiply to -6, add up to a B value of 1, +1. And if you try different combinations here, what you would get is 3 and -2. +3, -2. Right? Notice how that is going to work out because 3 times -2 would give us -6. 3 plus -2 is like 3 minus 2, right? This plus and minus become a minus. 3 minus 2 gives us +1. So those two values work right there. Now, because the A value is 1, we know that our final answer is just going to be those two values, basically. But let's do the full process over here just to warm up for the next section when that A value is not going to be 1, and in case your teacher maybe requires you to do this process. Another thing I want to mention actually with all of these, I mentioned this in previous videos, it doesn't matter which order you put these, so whether we put the +3x here, the -2x here, or the -2x and +3x here. Maybe with this one I'll actually show you both different ways. I've shown both ways in previous videos. It doesn't matter, it's the same process, you should get the same answer. So factoring by grouping, from these two we could take out an x. From these two we got a negative here, and the 2 goes into the 6, so we can take out a -2. Whenever this is negative here, this value, in front of these two, then you're always taking out a negative value. Sometimes it will just be a -1. We've done that in previous videos, but a lot of times it's going to be an actual value. Here, 2 goes into 6, so we could take out a -2. And we'd be left with x. -6 divided by -2 gives us +3. So then we could take out an x plus 3, and we're left with an x minus 2 like that, right? Which is what we were expecting. Now let's try this if we switched up the order for that decomposition. So let's say we did -2x plus 3x. Well, same thing, we would factor by grouping. From here we could now take out a 3, and then we could take out an x minus 2, and we're left with an x plus 30, right? Exact same thing that we got before, right? So it doesn't matter which order you decompose that b value in. Once you get those two values, if you do the correct factoring by grouping process, you should get the same answer. All right, so this here, part E, that factors into x minus 2 times x plus 3. As I've mentioned also in previous videos, haven't mentioned it yet here, but you can always check your answer by expanding your factored form, right? Because remember, expanding is the opposite of factoring. So going from here to here is factoring. Well, going from here to here is just expanding. So if you want to check your answer, you could take your factored expression, expand it, x squared, 3x, minus 2x, minus 6. These are like terms. Those factor into positive 1x. And notice that we end up with that same expression, right? So if you have time on a test, highly recommend expanding whatever factored form you get to make sure you get that original expression, just to be more confident with your answer. And then finally, moving on to part F, the last two. So we got 2x squared minus 10x minus 12, like that. First thing we always check, can we factor something out? And notice in this case, we can factor something out. We can take out a 2, right? Because 2 goes into 10 and 12, and 2 goes into 2 itself. So we could take out a 2 from everything. If we divide everything by 2, we'd end up with that right there. And then once you have something like this, I recommend just working with this bracket separately. So forget about the 2 and just pretend like you got this question to factor. So from here we can't factor anything else, so we go into the decomposition. A value is 1, B value is -5, C value is -6. The AC value would be 1 times -6, which would be -6. So then we got to find two numbers that multiply to that AC value and then add up to that B value of -5. Like that. And then the two numbers would be -6 and +1. Right? -6 times +1 gives us -6. -6 plus 1 gives us -5. So those are the two numbers. Because the A value is 1 here, for this quadratic we're looking at, we know that the final answer is just going to be those two values. Okay, but as usual, let's go through the full process and see if we get that. So decomposing this -5x into those two numbers, -6x plus 1x minus 6. From these two, we could take out an x. From these two, +1 here, we just take out a +1, and we're left with x minus 6. We're just left with that same term, right? Because 1 times something is just that something. So from here, we could take out an x minus 6, and we're left with an x plus 1, right? As expected. So this bracket over here, or this expression, factors into those two brackets. But remember, this is what we're working with. There's still that 2 in front. So basically, what would happen is we'd end up with, let's actually write the final answer here, 2 times this bracket turns into these two brackets. So we'd have x minus 6, x plus 1, like that, right? So this here factors into that. Notice now there's a coefficient in front, right? Because there's a coefficient over here. And then finally, part G. Notice this one, it's a little bit different because there is a negative leading coefficient. Whenever there's a negative leading coefficient, we're actually going to do more questions like this in a future video where we have to factor out negative leading coefficients, but thought I would include it in this video as well. Whenever I see a negative leading coefficient, I always take out a negative in order to turn this into a positive. And also in this case, because there's a 2 here, 16, 66, we can actually take out a 2 as well. So we're taking out a negative, we're taking out a 2, so we could take out a -2. So just be careful here. with your signs, basically all the signs are going to change. What you could do is you could just divide everything by -2 to make you feel more comfortable. So this cancel out. We're just left with an x squared. -16x divided by -2, those turn into a positive 8x. Positive 66 divided by -2 would give us minus 33. Like that. Okay, whenever I see a negative here, I always take out a negative. Now, a lot of times it'll just be a negative like 1 in front, or it might be, so like, again, we're going to do this in future videos, but let's say I had something like this, right? If I have just a -1 in front, then I take out that negative. And then basically all the signs change like that. And then I just factor that out with that -1 in front, right? I always change it so that leading coefficient is positive. Okay, in this case, we were able to take out a -2. Now, x squared plus 8x minus 33. Can't take anything out of that, so decomposition, a is 1, b is 8, c is -33. AC is -33. What two numbers multiply to -33 and add up to 8? And that would be 11 and -3. Right? 11 times -3 gives us -33. 11 plus -3 is 11 minus 3, which would give us positive 8. Because the a value is 1, as a shortcut, we know our final answer should be this. But let's see if we get that with the full process of decomposition. From these two, we could take out an x. Then from these two, we could take out, there's a negative here, and then a 3 goes into the 33 as well. So we could take out a -3, and we'd be left with x. -33 divided by -3 gives us positive 11. As expected, these brackets should be the same. They should always be the same. It's actually a nice check in the process to make sure you're on the right track. These two brackets, if you factor by grouping here, these two should always be the same if you pick those correct numbers from before. So take out that binomial common factor of x plus 11, and we're left with x minus 3, as expected, right? So this over here, let's not forget about the -2 we took out initially, and then this bracket factors into those two brackets. So we end up with that right there. Right, so just some more practice with decomposition. We've done quite a bit of questions now in this video and including the other previous videos. So at this point, you should be fairly comfortable, at least whenever that a value is 1, in factoring, in using decomposition with all that repetition. And so hopefully now when you're doing your homework, everything is going smoother.